Awesome. Let's do it. So, welcome to our session on building production video experiences with the Zoom Video SDK for web. We're really excited to share with you today some answers to some of the most commonly asked questions from developers, and we will uncover how developers can customize and optimize the Video SDK to fit their industry-specific use cases. My name is William Ezrine, and I am joined by my colleague James Coon. James and I are developer advocate engineers at Zoom, and more specifically, we work every day with developers who are using Zoom Video SDK. We work with these developers to answer their questions about the SDK, we take feature requests, and we open exciting new use cases with the technology. I'll briefly pass it over to James to introduce himself.
Awesome. Thank you, Will. As Will mentioned, my name is James. I work alongside Will on specifically the Video SDK with migration customers who are moving from other video platforms over to Zoom. So this is just kind of a collection of all of the questions and concerns and just kind of best practices that we have discovered over the time working with these customers. So excited to share that with y'all today.
Awesome. Thanks, James. So before we get started, we would like to share this with you, our safe harbor statement, which means that any forward or future indications of plans are tentative and subject to change without notice. So I'll keep this here for just a couple seconds, and then we can get started. Awesome. So what are we talking about today? Well, first, we'd like to open up the session with a quick discussion on the Zoom Video SDK and its tech stack. Once we get a good idea of how powerful the SDK is, we will discuss some of our most common advanced use cases that James and I have been asked throughout our time at Zoom, such as how to optimize audio and video quality, how to build a waiting room, accessing local media for AI processing, and more. Let's get started. So first up is Zoom Video SDK and its tech stack. So the Zoom Video SDK is Zoom's core meeting technology packaged for developers. Developers can build customized video experiences using the SDK without end users seeing that it's powered by Zoom. So you can see here that these two applications, they don't look like Zoom at all. However, they're powered with the powerful technology and infrastructure that powers Zoom meetings as well. So what does it like to look like to build with the Video SDK? Well, building with the SDK means developers can customize the video experience in UI UX without users knowing that it's Zoom. Customers can be confident in the technology, knowing that behind the scenes, Zoom's global infrastructure is doing the heavy lifting. And more so, you can be confident that the Video SDK will continue to innovate and improve. Zoom is committed to taking customer feedback and unlocking new powerful use cases, such as those that you'll see today. So I'd like to touch on the Zoom Video SDK web stack. The web is built on the same media stack that is used by millions using Zoom meetings. It's powered by WebAssembly. We're transitioning into building it with WebRTC as well as some customized audio codecs. So while we're discussing primarily the web video SDK platform, and most of the use cases and the tips that we're going to be sharing today are still applicable across a lot of these other platforms as well. So whatever we're talking about, it should be applicable to whatever you're building on. So while we talk a lot about audio and video and how Zoom really brings together some strong capabilities in this area, it's really helpful to mention that its strength lies in others as well. The Video SDK brings chat, file transfer, cloud recording, and live transcription and translation to the fold. So developers can really achieve a lot more than just with audio and video. It's powerful, but it's also easy to use. The developer experience with the Video SDK is awesome. As a developer myself, I love using it. We have many different ways to use the Video SDK, whether it be different package managers or distributions. And then finally, security. The Video SDK is powered by the same infrastructure and technology as Zoom Meetings, so you can be rest assured that using it will be secure for you and your customers. So I'm excited to jump into our first topic of the day, which is going to be JWT generation with metadata. So I guess before we get into this conversation, it's going to be important to understand what is a JSON Web Token or JWT, and how does it apply to the Video SDK. Well, in short, JSON Web Tokens, which are used very widely in web development, are a way that you can rest assured that the payload of a data being sent is um, hasn't been touched in transit, that it has integrity. Specifically with the Video SDK, JSON Web Tokens are used for authorization, and they have three parts to their structure. They have the header, the payload, and the signature. For the purposes of this conversation, the payload is going to be very important here. You can see an example of a JSON payload here on the bottom right. You can note that there are these required keys here that we use with the Video SDK, and we'll touch that on those later. And then above it, you can see an example of a signed JSON Web Token. So what is it like to generate a Video SDK JSON Web Token? Well, first, developers need to get their Video SDK key and secret from your Video SDK account dashboard. This is very easy to do, uh, and you should be able to get these and save them throughout this process. Once you do that, you can create your tokens payload using the required and optional keys. Here on the left, you can see our required keys. For example, like your Video SDK key, the role type of the user that is being used to authorize, the topic name of the session, as well as the expiration date of the token. And here on the bottom, you can see an example of a created signature. So what does this mean with the Video SDK? Well, a lot of times developers ask us, how can we pass user level information without additional server requests? How can we do it where we can ensure that it hasn't been manipulated in transit? Well, the answer lies in JSON Web Tokens. We're already requiring developers to use these to authorize and authenticate. However, oftentimes developers use the user identity key to pass this additional information. Well, this is totally okay. It comes with a character limit of 36 characters, and oftentimes developers need more than that. Well, developers can use an unlimited number of key value pairs with the payload of a JSON Web Token. This is really useful for scenarios where developers want to pass additional information while knowing that it hasn't been manipulated in transit without additional server requests. So our next topic of the day is going to be optimizing audio and video quality. First off, we'll touch base on some of the custom audio options with the sound options. Here we can see our first is original sound. Maybe you have a use case where you want to preserve the sound and not have any sort of background suppression. Well, you can do that using our original sound with high fidelity stereo audio options. Maybe inversely, you want to suppress some background noise. Maybe there's some loud noise in the background. Well, you can do it with our AI background noise suppression. Maybe you're trying to build with the Video SDK on devices that have low performance requirements. Well, you can use the audio compatibility mode to automatically enhance quality. And finally, with our sound options, the Video SDK allows granular audio control. This is really powerful as it means that developers have complete control over who and when's sound is played for who. This means that you can stream up to 2 audio channels per user. Here you can see just how easy it is to implement these. It's not something that takes a lot of work, it's quite simple. Here you can see that we've made it extremely customizable for developers, where you can enable these options before and after starting audio. So here with the original sound, you can see that we can simply pass in the stereo high fidelity options. Or with granular audio, you can control exactly who and which user is audio is being passed. And then finally, just like with the original sound, you can very easily enable and disable background noise suppression. As far as video goes, we have some awesome robust capabilities as well. With the Video SDK, we support streaming or sending up to 1080p and rendering up to 720p video streams. It's important to mention that Zoom will automatically optimize this for you depending on your noise, your device capabilities, and network conditions. Developers can set a virtual background or blur using or without using shared array buffer. However, we recommend using shared array buffer for better performance. Maybe you have a use case where you want to remote control a camera from afar. Well, you can use pan, tilt, and zoom with the Video SDK to control that. And then finally, just like with audio, the Video SDK has granular video control, which means that developers have the complete flexibility to choose when and where user videos are rendered. Developers can stream up to 2 video channels per user from 2 cameras. And here you can see again just how simple it is to use. The developer experience is really awesome. It's quite simple. See, for example, we can start video and pass in our HD options. Virtual background is really easy as well. And finally, granular video is awesome. We can use the attach video function, which allows us to specify which users and where we want to append the video. And with pan tilt zoom, it's a little bit more processed, but there's really not much work to do here. It's pretty simple, and you can follow these kind of instructions to achieve what you're looking for. So what is the cost of high video quality? Well, developers always like being able to stream the highest video quality everywhere in the application, but this isn't really necessary all the time. Users often expect live videos with no delays, so it's really important for developers to prioritize when and where to use high video quality. It's important to mention that sometimes we have CPU or performance requirements where we can't always have high quality streaming. So when is lower quality the better quality? Well, it depends on when and where you're using what size videos. We typically give developers a recommendation of using uh, lower quality videos, the lower or the smaller a tile is. For example, here you can see on the right, this is an example that we would often refer to as speaker view, where there is one main component and many listeners or participants around it. Here you can see that we'd recommend passing 720p quality for the main component and 180p for the listeners. You can also see that we have other recommendations with gallery view. The more tiles we have, the lower quality we're going to recommend, because oftentimes those tiles are going to be smaller, and so the perceived effect of the quality is going to be more minimal. So here I'll pass it over to James, who's going to tell us a little bit more about our other use cases and give you some additional insight.
Awesome, thank you, Will. As we continue on with advanced use cases for Video SDK, for the remainder of this presentation, we'll cover how to build a waiting room using subsessions, accessing local device media for AI processing, and controlling your Video SDK session with our REST API server-side endpoints. A waiting room can be a popular implementation as it allows you, the developer, to allow participants to wait inside of a session without being able to communicate with others. A perfect example of this would be an online telehealth therapy session, where you want to allow patients to enter the room even if they're early to a session, and then meet with the doctor when both parties are ready and present. During this section, we'll cover some high-level steps that you can take in your application to create this experience for your users. When looking at what is required for creating a subsession-based waiting room, we'll cover 5 distinct topics. Initializing a subsession client using the Zoom Video SDK, which will include creating that subsession room. 2, assigning the doctor and the patient to the subsession room. 3, opening the subsession room, which will automatically move the participants. 4, beginning the conversation by allowing camera and microphone access. And 5, closing the room, automatically moving the participants back to the main session. As a first step to building the waiting room, we need to initialize the subsession client. As demonstrated with the code snippet on the right, this can be done by calling the get subsession client method that is part of the video client namespace. Once we do that, we can call create subsessions with a value of 1 for the first positional argument. As this method can be used to create subsessions either automatically or manually, by just specifying 1, we are indicating to the video SDK that we would like for it to automatically generate the name for us. However, it's also important to note that this method can throw a JavaScript error, so we'll want to handle that accordingly as well before extracting the subsession that we created. Once we have the client, we can now assign the doctor and the patient to it, as well as any additional participants that you would like to be present, for example, loved ones. As the doctor is the host of the session, the get current user info method can be used to fetch their participant information. And for the remote participant, we recommend in a production environment to allow the doctor to select which participant they would like to assign. However, for demonstration, the code snippet here just filters via the participant with the name John and then adds them to the user list property. Now that we have both participants are assigned to the subsession, we can go ahead and open it. It's worth noting that this method has a few options that can be present. And for our use case, we'll make sure that the property is auto join subsession is present, which should be set to true, and wait seconds is present, which should be set to 0. The former property will automatically move all of the participants in the user list when it is opened, and the latter property will ensure that when the subsession is closed, it closes immediately. This is particularly important as the video SDK will default to a 60-second wait time otherwise. And now we can begin our conversation. Once the subsession has been opened, we can begin this conversation between all parties by listening to the user updated event. When this event fires, if subsession ID is present as a property in the JSON object, the user was moved into a subsession. So we can use this property to indicate to the application that we can now prompt them to turn on their audio and video. As a final step for this section, when the doctor or possibly a timer indicates that this visit is over, our application can close the subsession room, which will automatically move all the participants back to the main lobby, as we previously defined the wait seconds as 0, where they can be removed from the session or they can start a new subsession. As we just talked about, using subsessions to build a waiting room experience, or in other words, the pre-session experience, let's talk a little bit about some advanced use cases while the user is in the session. For example, accessing local device media for AI processing. Similar to the structure of our subsession waiting room, for accessing local device media, we'll explore the following steps in more detail. 1, we'll grab the primary video device, such as your camera. 2, we'll start both the local and remote video streams. 3, we'll process and handle the local video stream. And then 4, and finally, we'll destroy the local and remote video streams. Before we begin processing any media, we first need a media stream. To do this, we'll capture the device ID by calling the get devices method on Zoom's video SDK, filtering only video input devices. For the purposes of this presentation, we'll simply extract the first device ID. However, if you already know which device is the primary device, using, for example, some application state, that can also be chosen here. Now that we have the device ID that we'll be using, we can begin streaming to the video SDK using that device, as well as generating a new media stream by calling getUserMedia function. This media stream can be returned back to the calling function, as we'll explore in the next slide how this data can further be processed. Processing can mean a lot of things. You can capture a screenshot to offload it to AI for facial recognition, attention awareness, or for this presentation, we'll simply look at capturing a screenshot. As we're using the image capture API, at this time, this is marked as experimental, but has overall coverage in Chromium and Chromium-based browsers. Once the image has been captured, we can feed it into a file reader, which is then used to read the data as a base64 encoded data URL, which can then be sent elsewhere, such as your server, or as we mentioned before, an external AI service. As a last step, we'll cover how to destroy your local media. To do this, we'll first tell the Video SDK to stop capturing locally, and then, since we have a reference to the local media stream, we'll iterate through each of its tracks to ensure that this function resolves. To ensure that when this function resolves, there are no more handles capturing the input device. As we continue on, we've talked a lot about some use cases that you can use and develop your application using the Zoom Video SDK, but it's been more with an emphasis on client-side functionality. So now let's talk about the server side, using our REST APIs to explore some common topics, such as cloud recordings, in-session controls, and quality of service. As cloud recordings allow your video SDK to be recorded either automatically or manually, once they're finished recording and composing, they can be retrieved via our API, either by account or by session, as well as temporarily or permanently deleted. Cloud recording deletion is important to call out here, as you may not want your recordings to live on Zoom servers. We'll continue to host them for you. However, customers often find that they want to offload these recordings to their own storage devices or storage mediums, such as an S3 bucket from AWS or cloud storage from Google Cloud Platform. With our REST APIs, we make it easy to take those recordings, download them, and stream them to another platform if that is what you desire. When the session is active, Video SDK will allow you to control that session via the REST API as well. This includes starting, stopping, and pausing cloud recordings server-side. These controls exist client-side, or they can automatically be toggled on without developer intervention in the account settings. However, this endpoint gives you the flexibility to make that decision when and where you would like to perform these actions. Additionally, Video SDK comes with the ability to call into and out of a session via PSTN, think of your mobile device. With this endpoint, you can invite a user into the session by calling a phone number. This is a valuable feature for those that may be on the go or may not have a strong and stable internet connection. And finally, in addition to our PSTN offerings, you also have the ability to invite room connectors such as H323 or SIP protocol, all using the exact same API endpoint. For the last endpoint that we'll discuss here, let's talk about the quality of service endpoint. As your users are in session, they may experience issues that arise based off of device performance or even their internet connection. This endpoint gives you the metrics necessary to determine how data was received coming into and out of Zoom's servers. Data points such as your user's audio bitrate and jitter, or their video FPS and resolution. This endpoint will even provide additional information, such as the camera or microphone that they were using, and the data center that they were connected to, among a whole array of other data points. Though we often see customers make use of this endpoint to better understand the performance of their customers in session, I'd also like to call out that Zoom has a variety of webhooks as well, one of which is our session.alert webhook, which will send a request to your server when Zoom detects an unstable audio or video connection. And with that said, Will and I are here to answer any questions that may come up about the presentation that we just had. So we'll go ahead and open up the floor to the final portion of this talk where we will answer those questions. All right, let me look through. Okay, it looks like, Will, you are responding to some of the questions in chat. Let's see. Not seeing any new questions come in right now, so please feel free to open up the Q&A feature down at the bottom if you have any questions. Cool, cool. Give it maybe just one more minute. And if we don't have any questions, then we can go ahead and wrap up. All right. Oh, did you want to take this, Will?
Sure. Awesome. Well, thanks guys for joining. We're really awesome. Happy to have you guys here. We're really excited to see what you guys are going to build. Happy building with the Video SDK. Thanks for joining.
Awesome. Thank you, everybody, for joining. We hope you have a great day. Bye.